So hi, everyone. I think either everyone or most of the people here already know me. And my name is Ron Munitz, and I'm one of the people who lead this Embedded Everywhere meetup group. And today we're running it in the name of DevOps in the embedded world. So I would like to thank my friends from Stockholm for both speaking here and helping me at meeting people here. So thank you, Marlena. And I will not talk too much this time about our meetup. We usually give the intros and talk about the community building. We plan to have a conference on November, but right now all we have is international sponsors and international speakers. So if you are, and we got, obviously the situation is not always so stable. So it's another opportunity to tell people to submit your talks if you actually live in Israel, because who knows what will happen. The conference will be only in person if we do. Okay. So without further ado, let's get to business. Okay. I'll share my screen and we'll start talking. I will not, as always in the meetups, I will not introduce myself too much. However, I will give some references to other talks that we had before and some addendum that I put, because it can help you if you're interested in the domain of the discussion. Okay, so here goes. I'll try to move this to another tab maybe. So if somebody asks a question, maybe I will see the chat. Okay. All right. So the talk today is basically about my talk. My first talk is about the motivation for sometimes using ARM-built servers. And it actually has a real story that is a little bit happy and a little bit sad. Just like everything, this is a little bit about myself. Every time I change the things that I put there, because I've done a lot of things. And this is one of the oldest ones. And I actually put it when I was in our recent meetup in Amazon, where this particular talk was supposed to, at least part of it, was supposed to be delivered there as a preparation for our DevOps session. So why do we even need a DevOps session? So first of all, it's always good to learn from the experience of others, right? Now, there are two types of DevOps in a product or company. The first one is DevOps pros, which we don't have so many of them in companies that do embedded a lot of times, because most of the people will do DevOps to build the other type. The ones that are forced to be DevOps pros, at least temporarily, and they need to handle things they don't want to handle. And just to make things okay, like everywhere else, let's make it organized, let's make it, for more for the team and so on. But the thing is that they do it every once in a while, and when by the next time they will need to do it, a lot of new things will happen, like a lot of new technology. They'll need to learn a lot of things, and maybe the development board and the dev flow that they had is not identical to what happens, let's say, 3 years ago. And then it becomes time wasting and everybody's stressed, and us, like the developers, need to do a lot of things that we don't really want to do. We want to focus on the things that we are at least supposed to be good at doing. So there are two types, and I mean, it's a dichotomy, right? There is, if somebody says, hey, I'm both of them, they're lying for a fact, okay? They are lying. And if that someone is Claude or ChatGPT, well, they might be very good, but they're not excellent. They will not do everything perfectly for you, okay? So for this reason, I think that within our group, my intuition is usually okay about these things, that this is an interesting topic, DevOps, and I think it will be the first out of many. I will later give you opportunity to submit your talks, and you'll be able to do that. So let's start a little bit with the easy things, okay? So when we build stuff for embedded Linux or for embedded microcontrollers or whatever, life is good. Unless there are very specific ISAs, unless there are some instruction set extension things that some cross compilers don't support. But it's very, very, very rare, unless you are one of the people who actually make the SOC, that you will not be able to use cross compilers and cross tool chains built by others, and then everything is okay. For these things, I talk about it a lot in my embedded Linux courses. This is not the scope here. But many times, especially these days, you don't have a choice and life is not so good. You need to build very, very, very big systems like AOSP, like Yocto, like Buildroot. And then you pretty much don't have a choice but using cloud instances. Now, if you don't want to wait way too much, then you're likely going to have to use very expensive cloud instances or have your own build servers, which will be very expensive. For example, to build AOSP, you would need something that has like 96 cores. If you want to build the, let's say, AOSP 15 in less than 2 hours. From experience, actually, in Amazon, it's a long story and I want to keep it short. Maybe for a Q&A, you can ask me whatever you want, because I have good experience and interesting stories about it. You will have, by the way, sorry about the M. I see the people that are joining and it just driving my attention. So perhaps I will not look at that part of the screen. Okay, my apologies. That was me. Now back to the board. So basically, if you just want to build something like AOSP in, let's say, 8-core system with 64 gigs of RAM, it will take you like 10 hours these days, maybe more. Okay, so this is a good motivation for using stuff. But usually the DevOps people are not the people who build ROMs or build firmware, as they say. And for Yocto project, like even on a decent machine, you probably spend more than an hour. These are not the things that people know like from web development. So when you need a lot of resources and more cores and more memory help, a lot of times you don't have a choice but go like to the cloud. And for this, if you can either save costs or do things properly, then it can be very good, especially when trying to convince people about OCaml. Now, why am I mentioning it? Because let's say if you build any modern Yocto project these days, let's say that you use some NXP or like Qualcomm builds, you need like 200 gigs of disk space, regardless of the time. For Android, you need like 0.5 terabyte. So it's pretty much terrible. So basically, even though you can cross compile and everything is fine and there are build systems, those systems are, they're very greedy. They eat all your hard drive, all your RAM, all your everything, and it's not so simple as it is. So the motivation for this particular talks is not necessarily say, hey, DevOps is good, but actually tell a real story that happened and happened multiple times. It just happened recently again and in another levels. So it was a very good excuse to deliver a talk. So the motivation is time-consuming builds, huge build systems, which I covered. Customers of mine insisting of having a modern development workflow using modern framework like Electron or Tauri, that I will talk about later. Customers not understanding the cost of building AOSP, Yocto project or other huge projects, which is also the reason why I made like this build system that I talked about in Open Source Summit last year, I think, and throughout the course, throughout some of the meetups. And another motivation was that this was supposed to be given at Amazon Web Services and on a group that is working on ARM64 servers. So let's talk about things that we'll cover super quickly. The landscape, modern ARM64 embedded Linux. When we say modern, we mean AI. Of course, I got to say it once. So running all kinds of models, but we mostly mean rich UIs. People want to do embedded devices that have UI, and they want to use the front-end people that build the UI for other things. And they say, hey, it runs Linux, so let's run Linux on the embedded Linux as well. So that's fine. It has a lot of advantages, but there are also disadvantages, okay? And disadvantages are emphasized here. Modern developers, modern framework, modern is good, right? Amazing. However, those frameworks are always irrationally heavy. I mean, just to do something that you do, I don't know, with Qt or GTK, or LVDL, or like crafting it by your hand, and that would be fine and would not take too much disk space and not take too much time to build. It would take gigs over gigs over gigs, even for the simplest example application, as I will show later. So this is what I mean. This is what when I say rationally heavy framework, that's what I mean, okay? Now, this translates into sub-steps, which are like very large binaries, tons of dependencies, super complex build environment, and when you have sometimes resource constrained environments like embedded devices that maybe have, I don't know, maybe they have 8 gigs of eMMC, okay, and maybe they have 2 gigs of RAM, and that's like a lot, then this super genius developer that build application that runs everywhere with a modern framework, you'll need to start optimizing the high needs like forever for that. So that's not so amazing, okay? Now, when I say modern development frameworks, I have here like the screenshots, and there are links. I can post them, but if you just freeze, you can see them as well. For some examples of such frameworks, there is also like in the bottom a link for a very simple way to build Dockers for running each one of them, like on your computer, if you have Wayland, which you absolutely should have Wayland. And the examples for modern development framework would be using Chromium browser or Google Chrome. This is like a copy paste on one like the Tauri devices that I have. The second one would be Tauri. That it would be Electron. That if you use Visual Studio Code or Atom editor, then you're using it even if you don't know. And the third one would be Tauri. Now I said that they're modern. I said that they package a lot of things. What do I mean by that? So first, let's talk about the mechanisms and the isolation and how things work, like in an embedded Linux thing. And I will not take questions now. I'll take questions later. Okay. And so OpenWRT, how it avoided this mess. It doesn't avoid any of this mess if it runs any graphics. It's not a way to work. So basically, what we're going to have is the hardware itself up on the right-hand side. Maybe too zoomed in. Okay. Wow, it is too zoomed in. I don't know what happened. Let's retry. Thank you for pointing it out. It's a good thing I will. I have no idea why it happens. Maybe I'll move this to the other. I have no idea why it happens. Yeah, you know what? Let's just work without full screen. Maybe this would improve things. Okay, which maybe would. Yeah, now we can see it, right? So I have no idea what's wrong with the full screen. Probably some pipewire bug, but I don't know. Okay, but can we see it well enough? I mean, does it look okay? Feedback. Okay, so let's do it this way. So basically, if we have like a client, and when I say client, on the right-hand side, we have like the hardware, okay? So we have like the display, like a GPU, and we have like keyboard, mouse, touch, all these kind of things. Now, there would be a server or a compositor that works with it. That would be, for example, Weston. We talked about it a lot. You can see the YouTube channel. I will show you later like the link as well, but the channel is 1 minute. And then there is a playlist of recorded talks, which is where we see all our stuff. So we have like the compositor, and the compositor can accept all kinds of clients, and then they would receive input events and transmit graphics to the compositor. So this is how everything works. So the way things go is that the Wayland client or the X, we can have X, or if you want to be, very orthodox, there is also Wayback, which is relevant to use. It actually, you can run it on like the very same host that you have like the compositor, and you can, which many embedded frameworks do this time, run it like on a Docker. The only requirement is that you will be able to share information with a compositor, for example, via sockets, okay, or via setting the XDG runtime dir if you want to use Wayland, and via setting a Wayland display, for example, to Wayland -0, -1, and so on. So then if you do that and you have a way to share information, you can run your clients, for example, this Chromium or Electron or Tauri app, you can run them on a Docker. But if you want to render and use like a hardware acceleration or calculate all kinds of stuff, you must have the libraries. So wherever you take like your libraries from, it actually is significant. So I will try to do full screen again. So far, so good. No, it's bad. Sorry, I tried. So basically, the game plan is to exactly what I mentioned now. And if you separate into Docker, it's really good because it can isolate everything, build every application that you have separately, have the entire flows, and everything is great. Now, everything is great if you have a host that is easy to work with. That is, if you don't have like NVIDIA without the proper drivers, if you don't have some Qualcomm or NXP or Renaissance or whatever that has very specific DRM drivers, and you need to get them somehow. If these drivers support the APIs that you need, which is a lot of times not the case. I mean, for example, maybe you need FlowCon, or maybe you need OpenGL and not OpenGL ES, or maybe you need OpenGL ES3 and not OpenGL ES2. Whenever you want to port this kind of graphical application, the modern application, you will be in pain in most of the platforms, okay? Android is a different story because it has some compatibility plan, but it doesn't run Linux. Everything is different. So I made like this project, this Wayland Dockers. I will show an example of one of them, the Tauri one, that builds this so that you can have like a container and then run on your host. These are the example. Everything is in YouTube, okay? So I gave some extra information, and I thought I would finish the talk in 20 minutes. I will probably not do it. So I will not maybe show the videos, but I will give you references to them at a bit later, okay? So three types of frameworks. One, using Chromium. If you manage to run Chromium on your device, excellent. This is good in order to build like a web page. And if the web page uses backend that is in another planet and you are able to get to it, and it doesn't need like a very particular logic that has to do with the host and Chrome doesn't have access to, you win. You don't need anything. You can run Chrome in a kiosk mode, and that's it. Okay, it needs to be run sandbox, not a problem. Electron, something like what runs VS Code. Then the business logic would be Node.js, and the front end could be like in React or in whatever you want to do. But the important thing here is that it has a lot of dependencies because it needs Node. Okay, probably the application needs a lot of other dependencies. So before you start, you have a couple of gigs for sure. And you need Chromium browser, and not just your system Chromium browser, but the strategy of Electron.js is to put a browser inside like the app package. So even if you have like 5 different applications, then you bundle Chrome 5 times, which is not so ideal. Very important thing, Chromium uses a lot of knowledge on the particular hardware. So if you are Qualcomm or NXP and you want to run Chrome, you need to make very specific parts work, especially graphics. So if you don't make them work, you don't have Chrome, which is a problem that I will show when I say about the problem that we met like in a real project. Third one is Tauri. It's relatively new. Its latest version, Tauri version 2, can also run mobile. And it also runs a browser, but this one, as opposed to the other two, is not Chrome. So the thing here is that you can run your business logic in Rust, actually. And then there is like a binding that if anyone has never heard about it and wants to see some demo, maybe after Mariusz talk, I will, and after like we have some Q&A, I will show you how stuff works, like how the binding works and how like the server and the client works. It's pretty neat. It's pretty nice. Okay. The nice thing is that you can write everything completely in Rust, but usually people will just run the front end in a React or React with a JavaScript or TypeScript. And the browser that it uses is a system browser, but not a Chrome you want, but rather WebKit GTK. Okay. So this leads to tons of problems for people who actually just want to use Chromium. And it leads to even more problems when you want to have graphic acceleration, because a lot of things are not supported. So I have examples for all of these like in the playlist, and I have like the Docker project maybe I'll cover, okay? So speaking of what we want to do, by the way, any questions about what I said, not about OpenWRT? So far, so good. Okay. So we talked about having basically modern ARM64 landscape for embedded Linux, and I talked about what modern is. All right. Now let's talk about why ARM64. There is no reason to even answer it. Okay. Seriously, that's it. There is a slide just to have the slides. This is the dominant architecture. We can skip it. The problem is that almost always will be able to cross-compile and have build systems that work, but it doesn't happen always. Probably everything that we ever encountered is solved by cross-compilation and so on and so forth. But with the modern system, especially those by all the experts that, oh, we're just going to use Docker build X with this platform and this and that, there is a problem, because when you want to use building in a container that runs another host, it must be emulated. And when you run heavy workflows, a lot of times you will have all kinds of word crashes, because QEMU or your other hypervisors are just not able to do the things that you want to do. And this happens a lot in Node.js, and it happens in Tauri, and it happens in a lot of things. Sometimes it will just set fault for no apparent reason. It will work, it will not work, it denies it back. And other times it will crash consistently. Does anyone know what I'm talking about, or you never experienced these kind of things? When you use, for example, static QEMU or use Docker, actually uses static QEMU. Anybody ever met these kind of problems? If not, you should be happy, okay? So these kind of things are very, very, very problematic, okay? And if you want to do things that obviously require very specific hardware and acceleration or instruction set, then you need to do different things. Now, about emulation and virtualization, I did talk on the YouTube talk that is here, like Linux on MacBooks, where some of the concepts covered here are actually covered also there, but just know that the problem exists. So usually people these days will say, okay, we are great developers, we use containers for everything, so this is great, this is awesome, this is amazing, and it actually serves the DevOps principles very well. The problem is that these days, it's not necessarily a problem, but a lot of people want to use Docker on embedded devices, and they need to support it. This is problem number one. If they do it, things are pretty good, because then you can also use the Docker in Docker and do amazing stuff. Once you have Docker only one time working, you can do all their DevOps workflow over there and everybody's happy. But the other problem is the exact same problem that I mentioned before. QEMU or other hypervisor cannot always handle the workflows that you want to handle, which is why I mentioned it twice. So here goes CI/CD. In the problem that actually initiated this talk, that is building a Tauri app for ARM64 hardware, then building it with an AMD 64 using Docker, that is Docker with ARM64 platform, would take hours, okay? So this is not so amazing, even like on strong computer. Why? Because everything there is emulated and the build process is quite heavy. As opposed to it, building it like on a good ARM64 server would take less than 10 minutes, which is very, very, very significant, okay? So one can say, okay, no problem. I want to build for a target. I will build on the target itself. I will not use containers, I will not use QEMU, I will not use anything. But the targets are usually much, much, much weaker than the hosts that you would usually build on, right? So there are all kinds of things that one needs to take care of, and they can build on the targets and have like agents or runners in any CI/CD platform, or they can do other things. So these are also pain points that we have, and some of the pain points have to do with DevOps, but other have to do with actually with how we test, or how we deploy, or how we roll back, or how we update. So we talked about OTA several times. We'll talk again in the future, but that's it. So basically, there are a lot of like challenges to solve, and there are people who are experts and do DevOps. So what are like things that we want to do? We want to make them do the hard work or do the work, period. So some of the focus areas, I mentioned all of them, would be automation, build, testing, deployment, collaboration that I did not mention, working together. I said, what if you're not like a solo, you work on a team, you want to do that? And building faster that I mentioned, and of course, reproducing your build, which is super important. What's in it for us? Why do we need all this fast for? What do we need like infrastructure for that? Waste less time waiting and have others solve our problems. And there is a question here. How can you build on the target when the storage RAM needed exceeds a lot the capabilities of the target? Well, it really depends on which target. If it exceeds a lot, you can't do it. But on the target that I was using, I will talk about the particular target that is an NXP storage platform that I was using. I will answer it with respect to the very same one. It had 32 gigs of EMC, which is enough, and it had 4 gigs of RAM, which is also enough. But usually, believe my target is just a bad idea. If you have a lot of RAM, amazing. If not so good, because we're out the EMC. So speaking of this example, this is the thing that I needed to solve. Okay, so we had this Tortex development board. I never mentioned specific boards, but I've been working with it a couple of months. And the Israeli companies that are rivals of Tortex did not want to sponsor the meetup 5 years ago. So I don't mind supporting all of their competitors. But I was working on this, and it was a Tortex device. I don't work for Tortex, so it was easy. So it runs Linux. It has the NXP Vivante graphic accelerator, which is very, very, very problematic because it does not support a lot of things. Okay, and it can run accelerated Chromium because NXP took care of that. They have a fork of Chromium that is able to do that. So my client wanted to run a modern framework. I first show, hey, we can boot into Chromium kiosk device, and then I say, amazing, wow, this is great. Let's try and do some other frameworks. So we want to check Electron, but Electron would not work because the Chromium is not the Chromium that NXP packed in it. So that's a problem. So I said, okay, let's use Tauri. I like Rust. I heard about Tauri. Let's use that. And everything was nice. Everything was okay. And there are very good cross-compilation support for Rust. It's called Cross, actually, too. But you cannot build Tauri with it. So there is absolutely no way to build Tauri apps for a foreign architecture. You need to build it on the architecture itself, which limits you either to building like on a Docker and waiting an infinite amount of time and maybe failing, or building on the device itself, or build like on an ARM64 server. Okay. So this example that I had, this is exactly like what I did. I will look a little bit at the Docker file. So I did a copy paste here, but it will be just easier to open it. I mean, let's see the dependencies, okay? And maybe here full screen will work. I don't need full screen here. That's good. So let's look at the dependencies for it. And you know what? It's very fast. So let's just look on all of this. And I inherit from the Wayland client GLMark2 tests file because it's something that I know that I could run hardware acceleration on it. This is for x86. Also did it like for Cortex. And this particular client, it just gets like the Mesa DRI and the required libraries. And what it can do, it can run GLMark2 ES2 Wayland test. So one container just runs the client, another container as Weston, for example, as a Wayland competitor. And if we can run these tests, we can run anything on another client as long as it has like the right libraries. So the other Dockers inherit it as well. So on x86, there is no problem to run like a simple Electron app. We can do it with Electron Forge. So we can do it something like this. We must have Node.js. These are the dependencies. libgtk. The fonts are because otherwise you will have all this kind of like empty circles. In Electron, in order to have Wayland as a platform, you need to give it a Ozone platform hint, and you need to just have Electron disable sandbox to whatever. And if we go ahead and create an Electron app, this is called scaffolding, or getting it to set up everything that you want. Then you have like a very simple app that says like hello world, and I show the graphics for it. So this is how you would set up this. It takes some time, but it's not the end of the world, okay? If you have Node.js that runs there, you're all set. It builds whatever it needs to build, and you're good. Now for the Tauri, you need the other things. First of all, it does not package Chrome, so you need to have libwebkey dev, okay? And you need to have these folders because we want to use curl. Sorry, these tools because we want to use curl to install Rust, okay? To actually do like the first building. XDG utils is only needed if you want to bundle the image, so you can run it like in other devices as well. It's actually pretty nice. Vim is not really necessary. And for scaffolding, what you need to do is have cargo create Tauri app. Okay, we're going to select here like a template that is React. That's fine, and this will be like the front end. Install some things, and then we're going to build it. We can, if we do debug, it also, and we don't use no bundle, or we don't select the bundles, it will also build an RPM. It will build a Debian. It will build an app image. Now, there is a nice thing that you can do. You can use npm run Tauri dev, and then you will be able to do hot reload. It appears in the videos that I have. So we have tons of dependencies here, and these dependencies are terrible. They are a nightmare. Just to look how an executable looks, this is the LDD on it, okay? I did LDD on the release app, okay? And I'm not even going to look at the list. It's a big list. Tons of GTK, Cairo, whatever dependencies, okay? It has dependencies. So you need to have them somewhere on the device. So I'm not here to say it's a good thing, it's a bad thing, but it's not an amazing thing. Several GL library supports, and it's good. But the nice thing on something like this, that it would take only 12 megabytes if you're able to build it. So if you manage to satisfy the dependencies, mostly GTK actually, and libgtk, you can get away with something like a container of like 800 megabytes or 900 megabytes, have this 12 meg application, and you're pretty much set. And you can have very rich applications on that, okay? So this is how it goes, and let's just run it. This is how it looks like, okay? So this is like React.js. We greet, and then it says, hey, it says all kind of things. We can have something that is called hot reload, where we would just be able to modify like the JavaScript, and it will automatically load. If you modify things on the Tauri, on the Rust userland, then it takes more time. But I'm not going to get into this now. So all of these dependencies for like this little binary, they require a good flow unless you want to build tons of things and have I already got like the stats here. Just for the dependencies, before building, this is like a debugger, you have like 80 megs of NPM stuff. And after building, of cargo stuff, sorry, after building, you have like 4 gigs and something for an application for a binary of 12 megs. So it's not reasonable. Like the build is like way, way, way too much. So you don't have a choice, and for these kind of things, you absolutely have to have like a DevOps, a good DevOps strategy. So just to summarize the things that I've done in my tests, building Tauri for ARM64, the red one is terrible, okay? Not for compiling, you can't do it. Building with emulator, for me, Docker platform is an emulator because it is, and scaffolding apps would take hours over hours over hours over hours. Building on an ARM64 host, like my ToreDex device that's running, it has like 32 gigs of eMMC and 4 megs, so it's and 4 gigs of RAM, so it's reasonable. It will be reasonable, but it will take time. It will take a lot of time, maybe an hour or something like that. And building on a good ARM64 machine in the cloud is the best. Now, one can go ahead, start an ARM64 machine in each one of the cloud providers, or one can go and just run a runner on GitHub or whatever it is. And I will leave it to Marius to explain on some of like the considerations that you have when you want to run something. So this is just the beginning. I can talk for hours on this one, and maybe you can write in the chat if there are some particular things you want me to address, and then we can talk about it after Marius talk. And what I just want to tell you is that if you would like to talk about your experiences, then it's a very good idea for you to just go ahead and submit the talk. It will be very nice. So some of the things that we would be happy to talk about in subsequent meetups, whether virtual or not, would be like cross-compilation strategies for like huge systems, effective emulation and debugging, using containers, building robust CI/CD pipeline, testing systems, OTAs, which I've dealt with a lot, and also whatever it is that you guys do in your project. So please go ahead, start thinking what you want to present, because you're going to present hopefully in the next one, okay? And in this talk, this is like if you know that you want to talk about something, just take like this QR code and get ready to submitting, okay? It will be very nice, okay? I'll copy paste it, I'll put it in the chat as well. And what we talked about now is just the need for some other types of build. Just cross compiling doesn't always work. Very specific embedded related use case that I had, and actually several alternatives. And that's it. So thank you for taking the time to listen to me. And if you have any questions that you want to ask, I'll take a question or two. I say let's proceed to Mariu's talk. Okay. I will answer one question. So Ronnie asked like, how open WRT build avoid this mess? So I'm not sure what mess you meant, Ronnie. Care to elaborate? I hope, Ronnie, can you hear me? Yeah, of course. 500 gigs is for AOSP. It's for the Android open source build. Like it goes without saying. So let's say that these days, if you build like a very, very modern Linux kernel, then if you have everything like truncated, no history, no nothing, you will get with a couple of hundreds of megabytes for source code. And the build will probably take a couple of hundred of megabytes more, depending on what you build, of course. And then there will be fast, you can get away with, except for like some binary, some blobs, you can get away with not too much. It's not like a deal. When I say 500 gigabytes, I was talking about AOSP. And when I say 200 megabytes, like as a ballpark, this is what all modern like NXP related Yocto builds take. Like for the build itself, not necessarily for the image outside. Okay, so it was by no means like anything about modern build system. Like it's not a big deal. There are so many build systems also like for microcontrollers also. Okay, so thank you. So let's move to our next speaker.